So in this video, I'm going to discuss the random events and incomplete information. So we'll be looking at a class of games that incorporate asymmetric information, meaning not all players have equal information in the game. So think of some examples of asymmetric information from the real world. Let's say you're looking at a used car market. So there are two sides in the used car market. We have buyer of a used car and the seller of a used car. So the seller of the used car knows more about the quality of the car, whether it's a lemon or a peach. Whereas the buyer does not have that information. So here you're looking at information not being available to both sides in equal amount. So we can model asymmetric information games by considering the Bayesian games. So first of all, we'll look at, let's take a game where nature determines, so we're going to look at a game where the nature determines the type of a player. And so let's say, so nature gets to move first, and this is nature's node. And nature, is going to decide whether player one is going to be a friend to player two or is going to be an enemy to player two. Player one is going to observe nature's move, but the player two does not know whether she's facing a friend type or an enemy type. So let's say with probability P, nature determines that player one is going to be a friend type, and with probability 1 minus P, the player one will be an enemy to player two. Okay, and this is player one's node, depending on the type. So here you have player one, and then player one likes to give, let's say, gifts to player two. Okay, so both type of player one, whether it's friend type or enemy type, likes to give gifts. So to player two, gift to player two. Okay, so this is the gift. Player one gives gift as a friend to player two, and over here, the bottom node, player one gives gift to player two as an enemy. And at both nodes of player one, the other strategy player one has is to not give gift. So not as a friend type, not give gift, and not give gift as an enemy type. Okay. So player two, let's look at player two's node now. Player two does not know whether she is getting gift from a friend or an enemy. Okay, she doesn't know the type of player one, but she can either accept or reject the gift, right? So she can either accept or reject the gift. So those are the two strategies for player two to play the game. And then I can throw in the payoff. So let's make some assumption. Player one likes to give gift, and if the gift is accepted, then player one is happy. And player one doesn't like to be rejected. Either type of player one, whether it's friend type or enemy type, it does not like the gift to be rejected. And so let's say player one gives gift and player two accepts. So these are the nodes of player two, but player two doesn't know at which node she is playing. So player one gives gift and player two accepts. Let's say player one gets a payoff of 1 and player two gets a payoff of 1 as well. So let's suppose that gifts are, wrapped. So, player one gives gift either as a friend type or an enemy type. Player two doesn't know just by looking at the gift whether it's a good gift or a bad gift, right? So a good gift could be a jewelry wrapped, or a bad gift could be a rock wrapped. So those are the payoffs. If player one gives gift as a friend type and player two accepts, both of them will get a payoff of 1. But if player two rejects the gift, then player one gets -1 and player two gets 0. And if at the bottom node of player one, if player one gives gift as an enemy type, so keep in mind that unless player two opens up the gift, doesn't know whether she's facing an enemy or a friend. So here, the enemy type gives the gift and player two accepts and opens. Clearly, she's going to be worse off. So in this case, player one still gets 1, but player two gets -1. And because player one enjoys giving gift, he was an enemy type and it's accepted, he's happy. And if player two rejects, then player two is worse. The player one is worse off, and player two gets 0. And if player one does not give gift, right, so that the payoffs are 0 and 0. All right. So this is your an example of a random event, an incomplete information game. Here, player one has more information than player two, because player one knows what the nature has determined, right? Whether it's going to be a friend or an enemy to player two. But player two does not know that, right? So in that sense, this is an incomplete information game. Now, we'll be looking at solution concepts later on. But before we go there, I would like to convert this game into a normal form game, right? We are familiar with how to convert extensive form games into normal form games. Now we are going to use the same kind of technique here, but it's a little more involved. Because we have probabilities involved here, so we have to take the weighted, expected payoff here. So let's convert this game into a normal form game. We call it a Bayesian normal form game. So let's look at the Bayesian normal form game. So Bayesian. All right, so let's consider the Bayesian normal form game. So first we need to know the strategies of both players. So player one's strategy. So let's look at the strategy profile of player one. So player one can give a gift as a friend type, and then he has to specify what he's going to do at the bottom node when he's an enemy type, right? So he can give gifts there as well. So this is one strategy. And player one, can give a gift as a friend type at the top node, and at the bottom node, not give gift as an enemy type, right? So we can write NE, and then player one can, not give gift as a friend type and give gift as an enemy type, right? So that's the third strategy. And the fourth strategy of player one is not to give gift as either type, so NF and NE. Right, so these are the four strategies that are available to player one to play the game. And player two has two strategies. to play the game, either accept the gift or reject the gift, right? So this gives us the dimension of the Bayesian normal form game, and it is a 4x2 game, meaning 4 rows and 2 columns. So let's draw the normal form game. Let's do it here. So we have 2 types of player, player 1 and 2 players, and we have 4 strategies for player 1. So gift as a friend type and gift as an enemy type, and then gift as a friend type and not gift as an enemy type, and then not give gift as a friend type, but give gift as an enemy type, and then not give gift as friend type and enemy type. So these are the 4 strategies. And for player 2, either accept or reject. So these are the 4 strategies, 2 strategies for player 2. Next, we have to fill in the payoffs. And this is where you need to do a little bit more work here, because we have probabilities involved. So let me, give you, an example of how to do it. So let's say you're looking at, so let's use a different color. Let's say you're looking at player 1's strategy of giving gift as friend type and enemy type. And let's say player 2 accepts, right? So what would be the payoff to both players then? So let's write it down here. So let's keep it separate. So payoff of player 1, expected payoff from giving gift as a friend type and enemy type, and player 2 accepts the gift. So if you look at the game, go back to the extensive form game that I drew before here. So if player 1 gives gift as a friend type, right? So the probability of player 1 being friend is P, right? So P is the probability, and player 1 gives gift. So basically, probability of giving gift as a friend type is P, whatever that P is, right? Nature decides that. And in that case, and if player 2 accepts the gift, then player 1 gets 1. So 1 is the payoff that player 1 gets with a probability of P if player 2 accepts the gift. And then at the bottom node, player 1 can give gift as an enemy type, and if player 2 accepts the gift, then player 1 gets 1 again. So probability of player 1 being an enemy type is 1 minus P. So giving gift as an enemy, the probability of that is 1 minus P. So player 1 gets 1 when player 2 accepts the gift, and probability of giving gift as an enemy type is 1 minus P. So 1 times P is P plus 1 minus P. So P gets canceled out. So this will be equal to 1. So player 1 is going to get 1. That's the payoff of player 1. And next, let's calculate payoff of player 2. So player 2, expected payoff of player 2 when player 1 gives gift as a friend type and enemy type, and player 2 accepts the gift, right? So if you look at the payoff in the extensive form game, we have player 2 accepts the gift when it's coming from a friend, so you'll get 1, and probability of a friend is P. And then if player 2 accepts the gift when gift is given by the enemy type of player 1, then C gets -1. So -1 times 1 minus P. That's the probability of player 1 giving gift as an enemy type. So this simplifies to P minus 1 plus P. So 2P minus 1. So this is the payoff of player 2. 2p minus 1. Now, next, let's fill in the payoff for both players when player 2 rejects the gift, right? So player 1 gives gift as a friend and enemy type, and player 2 rejects the gift. What would be the payoff then? So U1 of GF, GE, and R. Player 2 rejects the gift. So player 1 will get -1 if the gift is rejected, right? So -1, and probability of player 1 being friend type is P, so -1 times P, plus again -1, because player, if player 1 is the enemy type, gives gift, and player 2 rejects, he still gets -1 times 1 minus P, right? So 1 minus P. So in this case, the payoff would be equal to 1 minus P times P, that's -P. And over here, -1 times 1 minus P, so that gives you -1 plus P. So that's equal to -1. So player 1 will get -1 here. Okay. And player 2, so let's look at the payoff of player 2 now. Give gift as a friend type, enemy type, and player 2 rejects the gift. So player 1 gives gift and player 2 rejects, right? So now what happens to player 2's payoff? So player 2, if player 2 rejects, gets 0 in both cases, right? So 0 times P plus 0 times 1 minus P. So in this case, the expected payoff is 0. So you can fill in 0 over here. All right, so let's do a little bit more. Let's say player 1 gives a gift as a friend and not give gift as an enemy, and player 2 accepts, right? So what would be the payoff in that case? So we can write down here player 1's expected payoff from strategy GF and NE, player 2 accepting it. So if player 1 gives gift as friend type and player 2 accepts, then player 1 gets 1 with a probability of P, 1 times P, plus at the bottom node, player 1 does not give gift, right? And player 2 accepts. So that's an out of equilibrium path, right? Doesn't matter what player 2 does, because game ends when player does not give gift, and they both receive 0, right? So 0 times 1 minus P. So the payoff would be equal to P plus 0, which is equal to P. So expected payoff for player 1, when player 1 gives gift as a friend type and not as an enemy type, and player 2 accepts the gift, right, will be P. And how about unknown caller? So similarly, we can calculate expected payoff of player 2 with the same strategy, G, F, N, E, and A. So if player 2 accepts the gift, right, from the friend type, so he gets 1 times P. And then player 1 does not give gift as an enemy type. So player 2, the strategy for player 2 is to accept, but that's, out of equilibrium path. So, it's out of the, the sequence we're playing. So in that case, here you get 0, 1 minus P. So once again, here it's P. So payoff for player 2 is also P in this. All right, so how about when player 2 rejects that, right? So we can do that exercise here too. Okay, so I don't have a space. Let's see if we can do that. Okay, let's go to the next page. Okay, so now player, we are looking at the payoffs for, so expected payoff of player 1 from the strategy GF, NE, and player 2 rejecting the offer, right? So in this case, what happens is player 1 gives gift and player 2 rejects the offer, right? So at the top node, player 1 will get -1 with a probability of P, and at the bottom node, player 1 does not give gift, right? So we'll end up with 0 here. So player 1 gets 0 with a probability 1 minus P. So the expected payoff is going to be -P. And for player 2, give gift as a friend type and not as an enemy type, and player 2 rejecting the gift. In this case, player 2 will get 0 in both cases, right? So 0 times P plus 0 times 1 minus P. So player 2's expected payoff is 0, right? So we can go back and fill in here. So over here we have -P for player 1 and 0 for player 2. All right. So similarly, we can fill up, here the payoffs for the remaining ones. So let me do it for you, and that's an exercise for you. You should be able to follow the explanation that I have given you so far, and you can fill in the rest. But let me give you the information. So when player 1, so look at this strategy. And in GF NE, right? So we have GF and NE. So in this case, player 2 accepts. Okay, so here we have P NF NE. Let me erase this. Okay, so okay. All right, so NFGE, so payoffs are 1 minus P and P minus 1 to player 2, and here P minus 1 to player 1, and 0 to player 2. And when both type doesn't give gift of player 1 and player 2 accepts, then we have 0 and 0. And over here, we have 0 and 0. So this is how you convert an incomplete information game into a Bayesian normal form game. So in the next video, we are going to look at the Nash equilibrium of this game.